Have you ever looked up at the night sky and wondered about the secrets hidden among the stars? Our solar system is a cosmic neighborhood filled with planets, moons, asteroids, each with its own story. Most of these celestial bodies follow a set of unwritten rules, spinning in the same direction like dancers in a well-rehearsed performance. A planet that decided to spin its own way, defying the cosmic norm. This isn't science fiction, it's a real-world mystery happening right next door, cosmically speaking. We're talking about Venus, a planet so close. To truly appreciate how strange Venus is, we first need to understand the normal rules of the cosmic game. Think back to the birth of our solar system, about 4.6 billion years ago. It all started with a gigantic cold and slow-spinning cloud. As it collapsed, it began to spin faster and faster, just like an ice skater pulling their arms in to speed up a spin. Instead, it flattened out into a massive rotating disk, like a giant celestial pizza. The rest of the material in the disk didn't get pulled into the sun. All of this material, gas dust. But Venus didn't get the memo. It chose to break the rules, to spin against the current. This isn't just a minor quirk. Venus is often called Earth's sister planet because they are similar in size and yet so profoundly strange. It's a world shrouded in thick, toxic clouds, hiding a surface hotter than a pizza oven, trapping heat and raising the surface temperature to a scorching 870 degrees Fahrenheit. But its greatest secret isn't its heat or its crushing atmosphere. It's the simple fact that it spins backward. Imagine a spinning top. You give it a good twist and it whirls in one direction. One of the most dramatic and widely considered explanations for Venus's backward spin is the giant impact hypothesis. This theory suggests that sometime in the early history of the solar system, when planets were still forming, Venus was struck by a massive object. We're not talking about a small asteroid, we're talking about something huge, perhaps the size of a small planet or a very large moon. The early solar system was a much more crowded and chaotic place than it is today. The impact would have been cataclysmic, an event of unimaginable scale and violence. The energy released would have been enough to melt the entire surface of Venus, depending on the angle and speed of the collision. The impact could have done one of two things. It could have hit Venus with such force that it literally stopped its original spin and started it spinning in the opposite direction. Another possibility is that the impact didn't directly reverse the spin, but instead knocked Venus completely upside down. If this happened, Venus would technically still be spinning in the same original direction, but because its north pole is now pointing down, its rotation appears backward. However, this hypothesis is difficult to prove. While a giant cosmic smash-up is a thrilling explanation, some scientists favor a less violent, more gradual process to explain Venus's strange spin. We're familiar with tides on Earth, where the moon's gravity pulls on our oceans. But tides don't just affect water. They affect solid planets and even atmospheres. The sun's gravity constantly tugs on Venus. Venus has an extremely dense atmosphere, about 90 times more massive than Earth's. This thick blanket of gas doesn't just sit there. It's in constant motion, heated by the sun. Combined with the friction between the atmosphere and the solid planet beneath it, it could have acted as a powerful brake. Over millions and millions of years, this gentle but persistent pull could have dramatically altered its rotation. The interaction between solid body tides and atmospheric tides could have eventually locked Venus into its current, slow, backward spin. The consequences of Venus's backward and incredibly slow rotation are just as mind-bending as the causes. The most famous consequence is the relationship between its day and its year. A Venusian year is about 225 Earth days. A Venusian sidereal day is 243 Earth days. That means a day is longer than a year. If you were born on Venus, you'd orbit the Sun before completing a single turn on your axis. Because Venus rotates backward while orbiting, the motions work against each other. One solar day on Venus is about 117 Earth days. You would get about 58 days of continuous daylight and about 58 days of continuous darkness. But Venus's thick atmosphere redistributes heat like a global blanket, so even the night side barely cools. So what would it actually be like to stand on the surface of Venus? Let's use our imagination and take a trip. First, forget about what you'd wear. No spacesuit currently designed could protect you. You're standing on a volcanic plain. a landscape of dark, basaltic rock stretching to the horizon. The ground beneath your feet is hot enough to glow faintly in the dark. Instead, you would be under a permanent, oppressive canopy of thick, yellowish-white clouds. The light that filters through this dense cloud deck would be dim and diffuse, but with an eerie, sulphurous orange-yellow tint. The horizon would seem closer and distorted, and the ground might appear to curve up slightly due to extreme atmospheric refraction. There would be no wind at the surface to kick up dust. The air is so dense and the rotations so slow that the surface is eerily still. But you might hear the faint, low rumble of distant thunder from the sulfuric acid clouds high above. The rain that falls from the clouds is corrosive sulfuric acid, but it evaporates in the intense heat long before it ever reaches the ground. It's a truly alien and inhospitable landscape. The study of Venus, with all its bizarre characteristics, is more than just an exercise in cosmic curiosity. It holds important lessons for us here on Earth. Venus serves as a cautionary tale, a real-life laboratory for what happens when the greenhouse effect runs amok. That matters as we discover thousands of exoplanets. We can't assume other worlds follow our solar system's rules. From an American perspective built on exploration, Venus is the ultimate challenge. Soviet Venera footage, landers surviving under 2 hours on the surface. Building long-lived Venus missions and surface rovers demands huge innovation. That desire drives us to build telescopes, launch space probes, and dedicate our lives to deciphering the clues the universe leaves for us. This journey to understand Venus is a testament to the power of human curiosity. So, the next time you see the bright evening or morning star in the sky, which is often the planet Venus, take a moment to think about its strange and wonderful story. If you enjoyed this journey into one of the biggest mysteries of our solar system, please show your support. Like this video, subscribe for more explorations of the cosmos, and share this with someone who would find it mind-blowing.